Hi, in this video we're going to be taking a look at some solubility curves and doing some practice problems. So these over here we have a chart of multiple solubility curves, and as you can see, ionic substances solubility increase as temperature increase, like NH4Cl, KCl, etc. Now gases solubility generally decreases as the temperature increases, like NH3 we have over here. Now on the right side we have our questions. Most substances on the graph show an increasing solubility with an increasing temperature. What are the exceptions, and in what state of matter do they exist? So first of all, SO2, NH3, and HCl are the exceptions, and they are all gases. Binary molecular compounds are always in gas form unless told otherwise. So gases do not act like ionic substances and increase in solubility as temperature increases. Now each curve shows the solubility for that substance changes as temperature changes. So what goes here is temperature. Now solubilities of substances whose curve show greater slopes are more affected or less affected by temperature. Greater slope means more affected. So over here, if we take a look at 50 grams of water saturated with potassium chlorate at 23 degrees Celsius. So 23 degrees Celsius is about right here. Then we have potassium chlorate, which is KClO3. And that line is over here. So when it's over here, KClO3 is this line and is approximately 10. So for every 100 grams of solute, there's 10. And this one we set a proportion. We have 10 grams for every 100 grams of solute, which is equal to X amount of grams of what we're looking for over 50 grams. It said 50 grams of water. So basically dividing by 2, and that gives an answer of 5 grams. Next, with the smallest mass of water required to dissolve completely, 23 grams of ammonium chloride, which is NH4Cl, which is this line over here. Now 40 degrees Celsius, which is here, approximately, let's say 46. So at 40 degrees, it's going to be 46 grams per 100 grams of water. As you can see, there's 100 grams of water. The label over here is 100 grams of solute. So, and now we're needing 23 grams. So we're going to make this equal to 23 grams of ammonium chloride over X grams of water, which is what we're looking for. So we do this together, and we should get something like 50. Number 3, a saturated solution of sodium nitrate in 100 grams of water at 40 degrees is heated to 50 degrees. What is the increasing solubility in grams per degree? So if we went from 40 degrees to 50 degrees of sodium nitrate, KNO3, which is over here, we're 40 degrees, increased to 50 degrees. So it's about 113 minus 105. So it increased by 8 from this to this. But we also need to find in grams per degree. So we're going to have to divide our 8 grams by our total change in temperature, which is 10 degrees Celsius, which gives us an answer of 0.8 grams per degree Celsius. Number 6. Which salt has solubility values that is least affected by changes in temperature? So least affected by changes in temperature basically means the smallest slope. So if we delete everything and we find the smallest slope, we can see that it is this line. And this line is NaCl. So which salt has the solubility values that has the least affected by changing temperature? NaCl, because it has the smallest slope. Now number 7, 30 grams of potassium chloride dissolving 100 grams of water at 45 degrees. How many additional grams will be needed to make the solution saturated at 80 degrees Celsius? So let's see what KCl is at 80 degrees Celsius. KCl at 80 degrees Celsius is approximately 52 grams at 80 degrees Celsius. Now we have 30 grams. We're given with 30 grams. So how much more do we need to get to 82 grams? So we simply minus 30 from 52, which gives an answer of 22 grams. We still need 22 more grams in order for the solution to be saturated at 80 degrees Celsius. Number 8. At what temperature do potassium chloride and potassium chloride have the same solubility? Potassium chloride is potassium chlorate is KClO3, which is this line. Potassium chloride is KCl, which is this line. So it's asking for when these 2 points intersect, which is the point over here, which is approximately 98 degrees. So it's 98 degrees. Number 9. At 50 degrees Celsius, water is saturated with sulfur dioxide. 50 degrees sulfur dioxide, SO2, so approximately 5. How many grams of sulfur dioxide must be added for the solution to saturate at 0 degrees? When 0 degrees, it's about 92. No, sorry, I was looking at the wrong line. It's about 22. So over here, it will be 22 minus 5. 22 at 0 degrees and 5 at 50 degrees. And that gives an answer of 17 grams. And that is the grams of sulfur dioxide that must be added to saturate the solution at 0 degrees. Next, number 10. We're going to skip this one because it is just like the one we just did. And number 11 as well. Number 12. Which compound is least soluble in water at 12 degrees? 12 degrees is this line. Now, least soluble basically means the smallest number, right? The smallest number. So the smallest number will be here, which is approximately 8 at KClO3. So which compound is least soluble? It's going to be KCl3. And number 13. At 8 degrees, 60 grams of potassium chloride is added to 100 grams of water. All right, at 80 degrees, we have 60 grams of KCl over here. We have 60 grams of added to, how many grams will not dissolve? So KCl, it will be approximately 52. This point is approximately 52. So at 80 degrees, only 52 of the 60 will dissolve. So how many will not dissolve? 8 grams. Number 14. A saturated solution of a compound contains 130 grams of solute in 100 grams of water. So 130 grams of solute is this line. So whatever the compound is, it has to be above this line. And only 3 substances ever go above these lines. It is Ki, NaNO3, and KNO3. So that's our 3 answers. Ki, NaNO3, and KNO3. Number 15 and number 16, we're going to skip these as well because it's very similar to the ones we did before. And number 17, a solution contains 100 grams of solute dissolved in 100 grams of water. All right, so our temperature is 50 degrees Celsius. So we're only going to be looking at this line. Then it asks, which is more concentrated? Saturated solution of KNO3. So KNO3, the maximum it will go is 90 at saturated. So KNO3 will have a concentration of 90. For KNO3, even though we have 100 grams of solution, only 90 will saturate in 100 grams of water. So this point is 90. And for NaNO3 at 50 degrees, 110 grams of solute can be dissolved for every 100 grams of water. If we're only given with 100 grams, it'll be 100 grams of NaNO3 for every 100 grams of water, and it's going to be unsaturated. And so our answer is NaNO3. Now number 15 is very similar to the one we just did before, except with different substances. So we're going to skip that one as well. Thank you for watching.